Welcome to the SafetyWorks Training Institute's presentation of Introduction to Hazard Communication. I'm here at the SafetyWorks Training Institute by myself, so I'm going to take my mask off. Well, hello. Our objective today is to outline why hazard communication is important and how employers are expected to communicate hazards to their employees. In 2012, the HAZCOM regulation changed to be aligned with the globally harmonized system of classification and labeling. Oftentimes that's called GHS. Now, the purpose was to have a worldwide universal system that anyone could understand. Workers have the right to know and understand the hazardous chemicals they use and how to work with them safely. How will you know? Well, manufacturers of chemicals must determine the physical and health hazards of their chemicals and communicate that information to those who distribute and use their products. Employers must train all employees to be able to find pertinent information about the hazardous chemicals employees use and are exposed to and how to understand that information. Now, we've got a little experiment. I'm going to put on gloves and safety glasses. Now, I have some common household chemicals that you could find in any home. This might make a mess. Hoping it doesn't. Here we go. So first off, we have some hydrogen peroxide and a little bit of dish soap, just because I like the color, here in this container. So hydrogen peroxide, what do we know about it? Well, until I look at a safety data sheet, I may not know a lot about it. I may not know what it reacts with. Now, I have in the cover some yeast, common product yeast. I would never have known that yeast and hydrogen peroxide have a reaction. So if I put this in here, and in this situation, it is what's known as an exothermic reaction. Essentially, the chemicals break apart when they're mixed together, and it forms different oxygen and water, and that breaking apart actually causes energy, and the energy causes heat. That's what's known as the exothermic reaction. And if we hold on to it, you could probably feel it get warm, and in time, you're gonna see it continue to bubble up. Because of that oxygen with the soap bubbles, you're gonna see bubbling going on. So even something as simple as peroxide and yeast can cause a reaction, excuse me, that generates heat. Now let's say we take two other common household products. Now you've probably done this before, but vinegar and baking soda. Inside this balloon is baking soda. So I'm gonna hold the cover, make sure it doesn't go anywhere. I'm gonna put the baking soda in with the vinegar. And as you can see, there was a pretty violent reaction in here. And essentially, when there was a reaction, it caused an endothermic reaction, and it released carbon dioxide into this balloon. So these two products together created carbon dioxide. So the question is carbon dioxide good or bad? Well, without a safety data sheet, you may not know. Now, carbon dioxide is what's known as an asphyxiant, which means if there was enough carbon dioxide in this room, it would push out the oxygen and it would be hard for me to breathe. Now here, in this quantity, it's not going to create an issue. In fact, when we breathe in oxygen, we breathe out carbon dioxide. So there's carbon dioxide anyway. But if we had large quantities of these two chemicals and they mix together in a confined space, that could be hazardous to someone's health. So why is this important? If during production you have an accidental spill, or you're fighting fires that involve chemicals, a reaction may cause a hazardous gas, a chemical mixture, or heat, which may become more harmful than the original chemicals. For instance, carbon dioxide is colorless, odorless gas in small quantities, but in that confined space, it can be a problem. Same thing with carbon monoxide. It is odorless and colorless, But if we didn't know where it might come from, we may be unaware that it's in your space and may cause a problem. Now, there are some things that will not fall under the hazard communication standard, such as the peroxide and the baking soda and the yeast. Those fall under the Food and Drug Administration. Food and alcoholic beverages, tobacco and tobacco products, pesticides, medical and veterinary devices and products. All of these things are regulated by, say, the EPA or the Food and Drug Administration, which means that they don't have to have the safety data sheets and the labeling requirements. In fact, their labeling requirements may be more stringent than OSHA's. There are other couple of exceptions, though. Wood or wood products. Typically, you're not going to see a safety data sheet for wood or a wood product. But if for some reason you're going to sand on that or cut it, then you've essentially made it into a product that may cause a hazard, such as wood dust. Okay, so having a safety data sheet for wood dust, if you're going to be modifying wood or wood products, then you'd want that in the workplace. Consumer products like cleaning products depends on the duration and frequency of use. So if I have a product such as this in my workplace, it's obviously labeled for the food and by another organization, the Food and Drug Administration, etc. And that's fine. But if I have a 5-gallon drum of a product and I'm going to put it into another container because I'm going to wash windows all day, then I would need a safety data sheet for that. So in small quantities, like I'd use at home, I'm going to use the label that's already on it. But if for some reason I'm using it in a larger quantity and capacity in the workplace, then I would definitely need a safety data sheet. Now, the employer has 5 major responsibilities under the HAZCOM standard. Now, first and foremost is making sure that there is a safety data sheet for every single product, and that every product coming in is labeled appropriately. Also, it's important to train employees to be able to read safety data sheets and read labels and understand those. An employer has to have a written HAZCOM program in the workplace that is accessible to employees. And lastly, they need to maintain a list of chemicals in the workplace. Now, as you can see by this label, it's important to make sure that all the information required by OSHA is on every product coming into the workplace. So every product has to have a label for physical and health hazards and must include the items in blue. As you can see in the items in blue, you're looking at the name of the product. We'll have pictograms, it will have precautionary statements, it will have the materials that it's made of. All these things are required by OSHA, as well as the manufacturer's contact information. Now, when we transfer materials into other containers, it's important that we label those containers exactly like the manufacturer's label, or have a product identifier in words, pictures, symbols, or combination thereof, which provides general information regarding the hazards. The point is if you have to label a container, your employer needs to train you how to do so. Here is a label that you may be using in the workplace. As you can see, the first line is the product identifier, which should match the safety data sheet and the chemical inventory list. Next, you will see pictograms, which are images depicting the physical or health hazards of the material. You may have a signal word, either danger or caution, depending on the level of hazard. Next will be hazard statements, which essentially give you the nature of the hazard, including, where appropriate, the degree of the hazard. Then there will be precautionary statements, and those are recommended measures to minimize or prevent adverse effects resulting from exposure to hazardous material. Now, you may have stationary process containers such as tanks, pipes, etc. in your workplace. They may not need the full label. They may use signs, placards, process sheets, or operating procedures. But if that is what they choose to do, the employer must be able to train employees to identify what is in those containers and where to get the information for their use. Now, here are 4 of the pictograms for the health hazards required. As you can see, the very first health hazard is what looks like, well, we call it the exploding chest, but it is for health hazards that are chronic, carcinogens, mutagens, or reproductive toxicity, maybe a respiratory sensitizer, or target organ toxicity. So anything that you are working with that has the very first pictogram of an exploding chest, as I say, is super important to make sure that you protect yourself from those hazards. Protecting yourself may require respiratory protection. It may be protective clothing or gloves, any number of things to protect yourself from these hazards. But these hazards tend to be long-term, over a period of time before the hazard presents itself. The next one is the skull and crossbones, and this is for acute hazards. The toxicity is fatal or toxic. It's a poison, and usually it's very quick and may cause death, things like fatal if swallowed. So if you see something with the skull and crossbones, it's super important to protect yourself with these as well, because they could potentially cause irreversible harm immediately. The next one is corrosion, and this may be corrosion to your skin, causing burns and eye damage. It may also be corrosive to metals. And lastly, the exclamation point is for irritants, and it causes some kind of irritation. It may be a respiratory irritant, it may be a skin irritant. Usually it's reversible in short term, but it's important to protect yourself from these hazards as well. These pictograms are for the physical hazards you may encounter with the products that you are using. The first one is the flammable symbol. And essentially these are for anything that will cause a flame and may cause fire, pyrophorics, self-heating. Some of these may need an ignition source. Some of them may ignite on their own, but in any case, a fire is the potential for these. The next one, the flame over the circle, is for oxidizers. And these essentially, these chemicals may give off oxygen. Now, fire loves oxygen, so it's super important never to store flammables and oxidizers together, as one will make the other one worse. So we want to be careful. The third one, compressed gas cylinders, is for compressed gases typically used for welding, but may also be found in healthcare. This picture of a compressed gas cylinder should be standing up because we never store them laying down. And lastly is an exploding bomb, and these are things that will explode. They're very reactive. A lot of the same properties of something as flammable, but it's going to have a much bigger reaction. Now, safety data sheets should be on hand for every hazardous chemical you have in the workplace. Every safety data sheet is now required to have standard 16 sections. These need to be readily accessible during your work shift. They may be kept in a primary location, but need to be immediately available in case of an emergency. But do not use hazardous chemicals if there is not a safety data sheet available. Now, section 1 through 8 contain information about the chemical for those who may need the information quickly. Emergencies such as medical, fire, and spills. Section 1 is the identification of the material. It identifies the chemical on the safety data sheet and its recommended uses. It provides contact information of the manufacturer. The second section is hazard identification, and it's going to list the chemicals that make up the product. The third section is the composition information on the ingredients. Safety data sheets will have 16 sections. Section 1 through 8 contain information about the chemicals for those who may need the information quickly, such as emergencies for medical, fire, and spills. Section 1 is the identification of the product, essentially what is its name, and the contact information of the manufacturer. Section 2, much of the information that will end up on your label, is the hazard identification section. It will tell you the hazards, it will give you the pictograms, and the information you need to protect yourself on the product. Section 3 is composition information, such as the ingredients of the chemical, what it's made up of. And Section 4 is first aid measures, essentially how to treat someone with an exposure. Section 5 is firefighting measures, how to fight a fire that may be caused by that chemical. Section 6 is accidental release measures, how essentially are we going to contain a spill and take care of it. Section 7 is handling and storage. How am I going to handle this product? What do I need to keep it away from when I store it? Maybe I need to keep it in a cold place, etc. And Section 8 is exposure controls and personal protective equipment. This will tell me the levels of exposure I may be exposed to without harm, and it will tell me the personal protective equipment to protect myself when handling this chemical. Section 9 is the physical and chemical properties. Essentially, how am I going to tell that this is the chemical I'm working with? It may be, what does it smell like? What does it look like? It may have things such as, is it heavier than air or lighter than air? All of its properties. Section 10 is stability and reactivity. And that tells me, such as yeast and hydrogen peroxide, what can I not have near it? What can I not use with it? Whatever is going to set it off, I need to have in Section 10. Section 11, 12, 13, 14, and 15 are all sections that are not mandatory. These are things that, such as toxicological information, ecological information, disposable considerations, how are we going to get rid of it? Section 14, how are we going to transport it? And Section 15, the regulatory information outside of what OSHA would want. So Section 9 is the physical and chemical properties. These identify the physical and chemical properties associated with the substance or the mixture. These things may be, what is its odor? What does it look like? Is it a liquid? Is it a powder? Is it heavier than air? Is it lighter than air? Is it explosive? Is it flammable? All of these will be in Section 9. Section 10 is the stability and reactivity of the product. Is it going to be a problem when mixed with another chemical? Section 11 is toxicological information, essentially the health effects of this product as it relates to having been tested on animals usually. Section 12 is the ecological information. What is the hazard or the impact to the environment? Section 13 is disposal considerations. Essentially, how do we dispose of this product if there's any left over? Section 14 is transportation information, and that's how we're going to transport it or ship it over the road. Section 15 is regulatory information, safety, health, and environmental regulations specific for the product that is not required by OSHA, maybe something else. And Section 16 is other information, which indicates when a safety data sheet is prepared, revised, etc., will be in this section. Now, not all sections are mandatory, but the sections 1 through 10 and 16 definitely are. Now, training to include location and how to access the written program is important, as well as the safety data sheets and the chemical inventory list. As an employee, I need to know where that written program is, how to find my safety data sheets, and the chemical inventory list, so I have a list of everything that's on site, so I am aware of what I may be exposed to. Now, the training also needs to be on how to read safety data sheets and identify hazards on labels. And it will be super important that employees can look at a label and know how to protect themselves by the information provided on it. Training must occur prior to using or being exposed to hazardous chemicals in the workplace and anytime new chemicals are introduced into the workplace. Training needs to include things such as methods and observation. How am I going to know what chemical I'm exposed to? What are their hazardous? What are their hazards? How are they monitored for? How do we know that we're exposed to it? The hazards of the chemicals in the work area, including the physical and health hazards. Now, an employer may not train on every single hazard, that every single chemical that's in a workplace. Some manufacturing facility may have literally thousands, but they may train you on the physical and health hazards and help you understand that when you're reading a label, what you are seeing at that point in time. Measures employees can take to protect themselves. So when they're exposed to these chemicals, what are the engineering controls, the work practice controls, emergency procedures, and personal protective equipment to protect them? And the details of the written hazard communication program, that should be covered in the training as well. Now, the written program needs to include things such as the criteria for labeling, incoming products and secondary products. The list of the hazardous chemicals need to be part of that program. How to obtain the labels from and the safety data sheets from the manufacturer. How to inform employees on the hazards of the chemicals, as well as non-routine tasks that they may be doing. And the written program and the safety data sheets must be accessible to employees at all times. And you should also make sure that these are also available to contractors who may be on your site as well. Now, included with the written program is a chemical inventory list, which should be updated as new chemicals are used in the workplace and taken off when they are no longer used in the workplace. Now, hazardous chemicals that have physical or health hazards, it's important that we understand as employees the state of matter. Is this going to be a gas, a liquid, or a particulate that I'm exposed to? I also need to understand the work operations such as welding, cutting, brazing, that changes in temperature, combustion that may create a hazardous environment or create a chemical hazard. And I need to also make sure that we use consistent product identifiers. It's quick and easy to say that I'm using bleach, but its real name is not bleach. So if I go to look up bleach, and I'm not going to find the safety data sheet for it, I have to look up its real name. And there needs to be a safety data sheet for everything that's on that inventory list. Now, you have the right to know and understand the chemicals you're going to be exposed to in the workplace. So be sure you do know and understand them and ask questions if you don't. For more information, please contact us at the SafetyWorks Training Institute. Join us for other safety and health topics here, and check us out at www.safetyworksmaine.gov. Thank you and have a safe day.